3. Internal resistance of power sources. The internal resistance of power sources results in potential drop inside the source, and hence the output voltage is reduced as soon as there is current flow. Experiment 2H. EMF of a battery.
We will study the effect of internal resistance of a power supply on the voltage it provides. Connect a voltmeter across the DC terminals of a power pack. Set the output of the power pack to 12 volts. Take the voltmeter reading. This is the EMF of the power supply. Now connect a 12-volt, 24-watt ray box lamp across the power pack in parallel with the voltmeter. Note the change in the voltmeter reading. Take the voltmeter reading. This is the voltage across the power supply or the ray box lamp. Is there any change in the voltmeter reading compared to the previous measurement?
All power supplies, including batteries and power packs, have internal resistance. Without the lamp, the voltmeter draws very little current, and the measured EMF, which is the terminal voltage, is almost equal to the EMF of the battery. When the lamp is connected, a much bigger current flow. The potential drop inside the battery due to its internal resistance reduces the terminal voltage across the source, which is the measured EMF. The circuit equation is written as epsilon equal V plus IR, where V is the terminal voltage and V equals IR, where R is the circuit resistance. You can see that the terminal voltage drops when the light bulb is connected. Before the light bulb is connected, the current flow is small, and the current becomes much bigger because of the small resistance of light bulb. You can see by comparing the results that the potential drop across the internal resistance is 2 volts, and the terminal voltage 4 volts drives the current I through the resistance R of the light bulb, in which I assume the voltmeter is ideal. To determine the internal resistance of a source, combinations of V and I are measured. From V equals epsilon minus IR, we know that a plot of V against I will give a slope of negative R, and V-intercept equals the EMF of the source. Alternatively, from V over I equals epsilon over I minus R, a plot of V over I against 1 over I gives a slope of epsilon and V over I intercept of negative R. The typical resistance of a dry cell is 0.5 ohm, and that of a low tension power supply is a few ohms. And that's why they are mostly neglected in calculations. Do check point 11 below.